Hi everybody. In this video, we're going to have a look at question 6H, part H. This is the short questions from the 2022 higher level paper. And before we get into it, I'll just remind you again, my usual tips. If you really want to make sure that you are exam ready and you really want to prove to yourself that you know what you're talking about, the best thing to do is to pause the video and go off and try this for yourself first. Close the books, pretend like you're almost in a little tiny mini test for a couple of minutes. See how far you get. If you get stuck, I would say just give yourself watch a bit of the video to kind of get you a hint. You might go, oh, yeah, I get it now. Okay, I forgot which one was which, and now I can keep going. So that you're, every time you do that, every little bit of confusion that you sit with and try to push through is you learning, as uncomfortable as it might be sometimes. If you're flying it and this is something that you really like and you get down to the end and you have an answer and you think it makes sense, you can either skip to the end of the video and check yourself or just go straight to my sample answer on the website, which should tell you, okay, I got it right, or got the same answer, or I didn't and there's something a bit wrong, and that's where the video could help you in as well. Okay, that's my idea of the video. It's so easy to watch me do it and think, well, that looks so grand. But when you sit with a blank piece of paper and a pen and you're in an exam hall, it might not seem so easy. So that's what you guys need to be ready for. Okay, let's just get into it. All right, this is so if you've watched a few videos, you'll know that I like calculation questions a lot. But I can see how that's often where people get stuck. You might be brilliant at remembering theory. Experiments might be absolutely your strong point. But when it comes to a calculation, you get a bit stuck, and that's what I'm hoping to help you with today. So here we have a lovely, it's electromagnetics question. I think it's lovely. In the short questions, these are nice. They're not asking you for anything particularly weird. You're going to end up using an equation, and they've given you everything in that equation bar one thing. So it's about as nice as it can be for a calculation question. Okay, the few things you need to know are which things are which, where they go, and I'm going to help you with that right now. So let's read the question to start with. We have a current carrying wire of length 20 centimeters is placed in a magnetic field. If you can picture such a thing, it can be hard to picture magnetic fields. When a current of 55 milliamps, watch out for the little m, flows in the wire, the maximum force it can experience is 130 micronewtons. So we have another micro in there. Calculate the magnetic flux density of the field. Okay, let's break this down. Let's break it down so that you can practice breaking it down yourself. So we've got a length of 20. Oh, is my pen not with me? Sorry, guys. The pen, the technology is sometimes a bit that slows me down. So it should be. Something's happening. It's white. What the world? One sec. I might have to put. Whoa. Okay, I think we're good. I don't know what was up with it, but I think we're ready to go. Sorry about that, guys. Let's go back to our question. So a current carrying wire has a length 20 centimeters. And so it's got, this is what I would do as well. And I'm going to just skip straight ahead and write this in meters because I know I'm going to have to do it anyway. So 20 centimeters is 0.2 meters. A current of 55 milliamps flows in the wire. Capital I is current, 55 milliamps. Now I had the milli and the micro. I'll check for you, but I'm pretty sure it's page 45 of the logs if you're wondering how to convert them. But I know them, and you'll know milli and micro hopefully by the end. So we've got a 10 to the minus 3 because milli means small, smaller amps. Okay, and the maximum force it can experience, so we're thinking a capital F, is 130 micronewtons. So my F is 130 micronewtons. And again, I'm just going to put everything into the SI unit straight away without any back and forth. Okay, so that's 130 by 10 to the minus 6. That's in the same place. I'm pretty sure it's page 45. I should have checked before I came on because I I kind of know them off by heart, and you will by the time you get in. And I actually would recommend knowing some of the common ones. Yeah, it's page 45. I just checked there for you. But if you are struggling to get familiar with them, like, so a lot of people watching the video might only be just starting fifth year. I might be like, how do you know this already? Page 45 for the 10 to the minus 3 and the 10 to the minus 6 business. Okay, that's just a note for you. That's not, you wouldn't write that in your exam. You would not, absolutely not have to waste your time writing that in exam. That's just for you guys watching the video to know, how did I get from like here to here, from here to here. Okay, right. Calculate the magnetic flux density of the field. So this is the thing I don't know. So hopefully by the time you're getting to the exam stage, you know magnetic flux density is given the capital letter B, and we're going, that's question mark. That's what I don't know. And see the way I've written out my letters and my numbers together, and I've got my length, my current, my force, and the thing that it's asking me for with my question mark. That's a really good approach to take every time you have a calculation question. Because for me anyway, and I have this little question, a couple of lines of question, it's not that clear, but when I do something like this, I start seeing the pattern of, oh, I've got a B, an F, an I, and an L. Okay, what does that remind me of? And that's the formula that you need to know. So I've got F is equal to B, I, L. The force is the magnetic flux density times the current times the length. And again, don't write this in your exam, but I'm just telling you now that you can find that on page 62. Okay, of your logs and formula tables. Here's my thing. If you've gotten this far, you are winning. Okay, you're winning because you have all the bits you need to do the question now. The last thing that might catch people, and I sometimes go, oh, it's just algebra. It's not just algebra. You need to be comfortable with algebra. And if you're not, tell your teacher, tell me, do some practice. Unfortunately, there's no amazing app you can just download into your brain, the algebra app, and now I can do algebra whenever I need to. It's just practice. And I like it because I think it's like a puzzle, but not everyone loves it. And the best way to get good at it is by practicing, okay? And if you need some help with that, I would be happy to give you a hand as well, okay? Now, let's do the just algebra, and I'll show you how I work it, okay? And there's lots of different ways, but we'll all follow those same algebraic rules. And once we do, we should end up in the same place at the end. We should end up with a magnetic flux density, okay? So I have all my information here, and I'm ready now to start plugging things into my equation. All right, I'm going to give myself a bit more space. Probably need some more again. I have big writing. So if F is B equals IL, you could, and I think I did this in another question, you could reassemble the equation so that you have just B on its own. I think a lot of people find, I like that way, but a lot of people find it harder, and you're running the risk that you rearrange it wrong. And even if you plug everything else, the numbers in right, if you've rearranged it wrong, you're not going to get the right answer. So for today, for this question, I've decided I'm going to keep the equation in the shape that I have it now and just slot my numbers in. I'm going to plug them in. So instead of F, I'm going to come straight down underneath. I'm going to put 130 by 10 to the minus 6 on that side of the equals. Okay, so I've got my force done. B is still a question mark for me, so I'll leave it as the letter B. I current is 55 by 10 to the minus 3. Superb. And my length is 20 centimeters or 0.2 meters. So you've got your plugging in bit done now. You need to bust out the calculators at this point. I'll leave my 130 for the moment, so I'm not really doing any proper algebra just yet. I'll leave my B because I have no choice, but what I'll do is I'll multiply my 55 by 10 to the minus 3 times 0.2 on my calculator, and my calculator gave it to me looking something like this. And just give whatever your calculator tells you. If this still gives you in scientific notation, use scientific notation, whatever suits you to work with. Okay, so that's the product of the current and the length, 0.011 times B, my unknown, my X, my mystery number for the moment. Okay, and hopefully, like, I really hope that I would expect that 5th and 6th year should be able to get B from this, but at the same time, if you're sitting there going, I can't, you need to say, okay, because the only silly question is the one you don't ask, all right? So the one you sit with and are uncomfortable with for much too long. So ask. I've got B. I'm going to decide to put B over here to make it neat, because my brain is programmed at this stage to have my unknown thing over here on this side of the equals and all the rest at the other side. And I'm going to have 130 by 10 to the minus 6, and I'm going to just divide it 0.011. Okay, so some people say that I'm dividing both sides by 0.011, and some people say I move a multiplying thing to the other side equals and it becomes a dividing. I don't mind. You probably learned a certain way in second or third year, whichever one works for you, whichever one you already know, stick to it. This is not the time to change up all that stuff on yourself and make it harder. Put it into your calculator. You've got 130 by 10 to the minus 6 divided by 0.011. And you should get 0.0118 Tesla. Tesla are the units for magnetic flux density, okay? And that's it for 7 marks. So if this question suited you, that's an easy 7 marks. If you remembered your equation, if you were able to break, I think the hard bit for people is breaking a chunk of text and making it into maths, okay? So that's why I suggest that you do this thing where you write all the different things down with their letters, and then you start seeing what you have and what you're missing. And that's not gaining you any marks. The examiners aren't looking for this, but if you do it for yourself, it makes it really obvious which equation to use, and you're not stressing. It just helps things to be a bit clearer, basically, okay? And then the other thing that might catch you is your algebra. So that's just something you have to brush up on and practice and get. I would call it kind of fluent to it, because it is almost like a language of itself, okay? Right, that's it for this question. That's how I would answer it. If you got that far, you got your full marks, and you're able to move on to some meatier questions in the long question section. I would love to hear your questions if there's anything in this that wasn't clear, if I went too fast, or you had problems with audio or visual or anything at all, please let me know. I am continuing to go through last year's paper just so that there's videos up there that people can use, but I am more than happy to. In fact, I prefer if I was getting a question in and I had to go way back to 2005 and answer a question, because that's what someone was working on, and I got to help you out with a video showing you how to do it. So please do send in questions. If you are sending in questions, try to be as specific as possible so that I can help you as best I can. But if you are just kind of generally stuck on something and you want me to talk about that, that's grand too. I can do that. So thank you for watching. I hope you found it helpful, and let me know if there's other things that you'd like to look at. Bye.